rest, motion. Then we did distance and displacement.
Yes.
Speed and velocity.
Mhm.
Then I told you about scalar and vector quantities. Right, this is all which we have covered till now. So just a quick recap.
Mom, I remember till like speed, but I forgot displacement, scalar, vector quantity.
Okay, I'll just give you a quick recap. So starting from scalar and vector quantities, in physics, we study every, what you will say, these distance, displacement, and anything else that we study, like force, energy, all these quantities, we classify them under two different types. One is scalar and the other is vector. Okay. For scalar, we say that those quantities which only have magnitude and no direction, those are scalar quantities. And the quantities which have magnitude along with direction, those are the vector quantities. So because of the direction part, we have to add plus or minus sign before the magnitude. Let's say I'm saying force is 2 Newton. Because force is a vector quantity, I will have to write plus 2 or minus 2, right? To classify or to mention, specify in which direction the force is acting, right? Plus and minus tells us that. I told you this quadrant system, that when we go in this direction, it is positive. When we go upwards, it's positive. When we go in this direction, negative. And when we go downwards, also negative, right? So by this system only, you have to remember the signs, plus or minus, right? Then about distance and displacement, both are similar terms. Both SI unit for both of these is meters, represented by small m, right? And we represented displacement by small s, distance by small d. And the major difference between both is that distance is a scalar quantity, displacement is a vector quantity. In case of displacement, direction matters for us, right? And distance was the total path covered by a body. Wherever the body went, wherever the object went, the total path measured in meters is the distance traveled by that object. But in case of displacement, we defined it as the shortest path. It was the shortest path between the initial and the final point. Do you remember it now? We discussed it.
Yes, ma'am, I remember. I just forgot velocity, scalar, and vector.
Yeah. Let's say a body started from A, it went in this path, and then it came back to A. So for displacement, we are only concerned with the initial and the final position. Now in this situation, it is the same. It started from A and came back to A. Hence, the total displacement will be 0. Right? Final initial same. So because of that, shortest distance will be 0. But if I have to calculate distance, I will have to calculate all this path in meters. Then only I will get the distance. Now in case of speed and velocity, I told you that let us represent both of them as small v. In case of speed, the formula was distance upon time. In case of velocity, it was displacement upon time. And velocity is vector, speed is scalar. Again, the same thing. In case of speed, only magnitude matters. Like I'm saying, a car is moving with 30 km/h speed, right? So this is the speed of that car. I'm not concerned about the direction in this case. But if I'm saying a body or a car is moving with 30 km/h in towards east. Now this gives us a direction towards east. That means towards this right direction. We generally take the directions like this: north, east, west, and south, right? So if I'm saying car is moving with this speed towards east, this gives me a direction also. So I can write the speed is 30 km/h. Now this is not only the speed, it becomes the velocity because plus sign is also involved, right? This is the difference between speed and velocity. Now do you remember what all we discussed?
We discussed scalar quantity, which has magnitude, and vector quantity has magnitude and direction. And we discussed speed is like velocity, which like speed is equal to speed distance by time, and velocity is equal to, I forgot that, but I was going to ask you.
Displacement upon time.
Displacement.
Right. So now moving on to the next topic. I hope this much is clear. No, I hope you don't have any doubts on this. Okay, good. So moving on to the next topic, we can define motion in 2 ways. Maybe I have mentioned this in the last class, but I'm not sure about it, so I will just tell you again.
Yeah, we did.
We did?
Yeah.
Okay. So I'll do it briefly. Motion can be of 2 types: uniform motion and non-uniform motion. In case of uniform, we might have discussed that when the body covers equal distance
and equal intervals of time.
Yes, very good. In equal interval of time. And in case of non-uniform, I told you to keep one thing constant.
Mm.
That was the time, which we kept constant.
Mm.
So it was
Or
unequal.
equal
Yes.
distance and equal interval of time.
Yes, very good. Absolutely right. This was our definition for uniform and non-uniform. Now, a new term or a new quantity arises from this thing only. Now, if I'm saying a body is in uniform motion, what I'm trying to say is that it is moving with the same speed, right? And I told you that it can be same velocity, only condition applied, the direction remains the same. If I'm not changing the direction is same, then velocity can also be uniform. So I can say yes, body is in uniform motion. So let's say a body is moving with 30 km per hour. So in this situation, it is in uniform motion. Let's say it's a car. But I also told you that this is not possible in practical situations. We have to sometimes increase our speed, sometimes we have to decrease our speed, depending upon the situation. So when we are constantly changing the speed, like increasing or decreasing, we have to apply brakes or apply or like put pressure on that accelerator. That's when the car will speed up. So now a term arises from this non-uniform motion only. We can also call non-uniform motion as accelerated motion or decelerated motion. Accelerated when the speed is increasing. So accelerate something means to increase the speed, right? When the speed is increasing, then it will be accelerated. But when it's decreasing, we will call it as decelerated. Simple. Now, the term or the quantity I'm talking about, which arises from this, is known as acceleration, right? And we represent it as small a. So this is the amount. How will you calculate this, or what does it really mean? Is that initially your body was moving, car was moving at a certain speed, but you increased it to a certain level. Let's say it was moving at 30 km per hour, but you increased it to 60 km per hour, right? So you increase the speed. Now the difference between that increase in speed with respect to time is also important. Like how much time it took for me to increase the speed up to this level. So time is also, we have to take time also in consideration. So when we define acceleration, it is defined as rate of change of velocity. Now from here you will see that we will use the term speed and distance comparatively less. Mainly we will use displacement and velocity, because moving ahead from this point, maximum things involves direction also, which means acceleration also includes direction. So it is also a vector quantity, because I told you vector quantities are those which includes direction, right? So always remember this, that whenever we talk about rate, right, whenever you see this term rate in a definition, it should click automatically in your mind that we are talking with respect to time. Whenever there is this rate thing with respect to time. So if I have to like give the formula for acceleration is small a is equals to, I'm talking about change of velocity. That means, first of all, I'm writing the formula, then I'll explain. This is the formula. Now I told you velocity is represented as small v, right? But there is quick modification, like small modification. We mostly represent final velocity as v and initial velocity as u, small u. And t is obviously the time here. So what I'm doing here, simply I'm taking the difference between the two velocities, final minus initial. And what I'm talking about the change of the velocity with respect to time. That's why the time came in denominator, right? So this is the formula for acceleration. This will be the definition, rate of change of velocity. Is it clear? And what acceleration is basically? It is simply the increase in speed that we did. Now, there we can also like there are other words for acceleration also. We can also call it as deceleration, or I can call it as retardation. Now again the same thing. If the speed is increasing, if the velocity is increasing, then I will call it as acceleration because I'm accelerating it. And if this velocity is decreasing, which happens in the case when we apply brakes, to our car, automatically our velocity will decrease. In that case, we will like represent it with small a only. The only difference will come that it will be represented with a negative sign. You will see gradually when we will solve numericals, you will see how it's represented, right? So this will be this is the acceleration. Now what will be its SI unit? Now you tell me what is the SI unit of speed or velocity. Formula for velocity was displacement upon time, right? So what was the SI unit of displacement?
It was displacement by time.
Velocity is equals to displacement upon time. This is its formula. I'm asking what was the SI unit? How do I represent displacement? I just told you in the starting of this class only. The SI unit of displacement.
Meter by no.
It's simply meters, right?
Oh,
So it's the path, only the path which we are measuring, right? It's simply meters. And SI unit of time is seconds. So SI unit for velocity is meter per second. And in the last class, I told you can also write it. Either you can write it meter slash second, that means meter per second, or you can write meter inverse, meter second inverse, like this, right? So we know that this is the SI unit of speed or velocity. Now, how can you calculate the SI unit for any quantity? Even if you don't remember it, you can simply calculate it by using the formula. Now, in the numerator, I have the velocity only. So obviously, in the numerator, I will have this unit, right? And in the denominator, I'm having time again. That means second. I don't have anything below this, so I can keep one here. So I hope you know, whenever this situation is there, you will write this as it is. And if I want to bring it in front of this quantity, it becomes reversed. We have to reverse it. It will become this. Second into second will become second square. Right? So now either SI unit for acceleration is either you can write meter per second square, or you can write meter second inverse, but inverse with the -2 power will be -2. These are the two representations for the SI unit of acceleration. So you have to strictly remember these units, because if you write only the answer like in the numeric value, like you write 2, you didn't place the unit, so marks will be deducted for that.
Yeah.
Okay. So for distance and displacement, we said it is meters. For time, we said seconds. For speed or velocity, it is meter per second. For acceleration, it is meter per second square. Right? In case of this speed or velocity, I also told you that we can also place the we can also use this unit, kilometer per hour. Right? But for acceleration, this is the only unit which we use. It will very rare it happens that we use this unit, like in terms of kilometers or hours. Otherwise, it's always meter per second square. Okay, if you want to write it, or just
Yes, I'll write it. 10 ma'am.
So, just a simple, quick question.
Mhm.
What is the clarity about the acceleration? So, we are talking about a body which changes its velocity from this to this in
Mhm.
this shine. You have to find the acceleration. So,
Mhm.
as I told you, always write what is given to you first.
Mhm.
Right? So, what's given? What's the initial velocity?
Uh, is it 5? No, ma'am.
Yes,
Yeah.
it's 5 because it's clearly stating that a body is changing its velocity from 5 meter per second to 25. Like it was initially it was moving at this velocity and it
Mhm.
changed its velocity. That it means the final velocity will be 25.
Yeah.
And how much time did it take? It
10
takes 10
seconds.
seconds. So very simple. You know that formula
Yeah,
for
acceleration is equal to, yeah, I got it. Yeah. I got it.
yes, p minus u upon t. Now another thing that is important, which you have to always check while you are writing this given part only. Always
Mhm.
quickly check whether the units are okay. Like here we can say it, see it's meter per second, second. But it might be the case you might have like they might have given you this in kilometer per hour. So what will you do in that case? You will first change this unit into meter per second, then only you will move forward. Because if you place your values with different units in the formula, answer will be wrong always.
Mhm.
So always check the units first. So here we are good to go because the units are same.
Mhm.
So 25 minus 5 on 10. Its answer is simple. Acceleration will be 2 meter per second square.
Understood.
Right?
Yeah.
Now in this case, you can clearly now I will tell you what I was saying about positive or negative.
Mhm.
Now in this case, the final velocity is more as compared to that of initial velocity. That means initially the car was moving at a lower speed, but it increased its speed to a certain value, right? So because we always place the final velocity in front, if the final velocity is more, every time our acceleration will be positive. You can clearly here we have positive acceleration, right? Because 25 minus 5 will be 20, not minus 20. So which proves that this is acceleration. The speed is increasing in this case. But let's say I gave you an example that the body was moving at a speed, at a velocity 25 meter per second. So because it was moving at this velocity, that means this will be its initial velocity. And let's say you applied brakes. You applied brakes and after some time the car stopped. So what will be the final velocity? When the car stopped, it's not moving anymore.
Can you repeat one more time? I couldn't hear you.
Sorry,
Can you repeat one more time? I couldn't hear you now.
I'm asking, am I audible now?
Yeah, my internet's kind of slow today, so.
Okay, I'm asking that the car was moving at this velocity initially. So that gives us the initial velocity. But after some time, you applied brakes. And the moment you applied brakes, the velocity slowed down and a moment came when the car stopped. So, and let's say it took 25 seconds to do this, like for the car to stop. Now, what will be the final velocity in this case?
0.
Hmm?
Why not 0?
It will be simply 0. Because I'm saying initially the car was moving and then it stopped. Like it's not moving anymore. So that means it's not covering any distance anymore. Now, because it's not covering any distance, velocity or displacement, velocity was displacement upon time, and because displacement is 0, the velocity will become 0. Right? If a body is at rest, always remember there two situations will come in the questions. Either they can start the body from rest. If a body is starting from rest, that means its initial velocity is 0. I'm saying that Ria was sitting on a bench and then she started moving and gained a velocity of let's say 10 meter per second. So because I said initially you were sitting, you were not moving. So your initial velocity in that case will be 0, obviously. But your final will be 10 because you gained that velocity. Other case that they ask in questions generally is that a car or whatever, a train, anybody was moving initially at a speed, let's say 100 meter per second, and then applied brakes. We applied brakes and it stopped. Now, if the body has stopped, that means it's not moving anymore. And because it's not moving anymore, the final velocity in that case will be 0. So here v will be 0 because v represents small v as final velocity. So it will be 0. Now, if you have to calculate acceleration for this case, we know that a is equals to v minus 2 upon t. V is 0, u is minus 25. Upon time, we have 25. Now, 0, like, what will be the sign in this case?
Since it's minus, there will be only 25 and denominator, so it's going to be 1.
The answer will be 1. Plus 0 minus 25. What will be the sign? It will be minus 25. Right, upon 25, and we will cancel this out, and the answer will be minus 1 meter per second square. This will be our acceleration. Now, in this case, what this minus is representing, whenever acceleration comes in minus or it's given to you in question, maybe they will not give you the sign directly. They will maybe write the speed is decreasing. Then it's automatic. It should be automatic in your head that I have to take acceleration negative because the speed is decreasing. Negative acceleration clearly means that the speed or velocity is decreasing. Hence, we will not call here it acceleration. However, we will represent it with small a only, but we call it as deceleration. This one. Either you can call it as deceleration or you can call it as retardation in this case. But in general terms, we write acceleration only. But if we have to write it correctly, it's retardation. Right? I hope acceleration is clear to you.
Yeah.
Okay. Now there is also one concept of average speed and average velocity. Have you heard this term before, average, when we calculate average of something?
Yeah.
What was the formula for speed? Distance by time. But if I talk about average speed, I have to simply take total distance upon total time. We mainly do this in stats. In stats, we do this average. We calculate the average. So what we do, we simply add up all the values upon total things, like total number of things. Then we get the average, something like that. So average means some like adding up all the things and then calculating the ratio. So in case of speed, if I'm talking about average speed, I will simply write total distance covered upon total time taken. Right? And in case of average velocity, it will be total displacement upon total time. Now, this might not be making much sense to you right now. But once we will do the numericals based on this, then it will make much more sense. Right?
Yes.
Now, after this, I just have to see. Now, look, in this chapter motion, they have explained everything in two ways. One is the basic ways in terms of formulas, which we are discussing, and the other is by graphical representation. So what I will do, let's do one thing. Today, let's read complete these formulas completely, okay, and discuss whatever the quantities are. In the next class, or maybe another next class, we might need 2 more classes for this if we have to be done with the numericals perfectly, right? So let's be clear with the formula part today. What I want you is to learn all these formulas, be clear with the formulas and the SI units and stuff. Like you should know the basics.
Yeah.
For the next class, actually, right? Once this part is clear, then we can do the numericals in the next class. Like, and if we need another class, then we'll continue the numericals, and if not, we will start the graphical representation later.
Okay.
I will keep it separate. I'm not merging the topics because it might cause confusion. So we will do it later.
All right.
So till now we have done speed, distance, displacement, speed, velocity, uniform motion, non-uniform motion, acceleration, or retardation in certain cases if the sign is negative or if the speed is decreasing or velocity is decreasing, right? Now next comes and then we did the average velocity and average speed, which is pretty much same. You just have to remember the total part. We have to do it like that. Now there we have basically Newton gave laws of motion also, but there are basically 3 equations of motion which are important. We study equations in maths also, but physics is also pretty much maths, just like maths only, right?
Yeah.
So we have 3 equations of motions which we will be using in most of our numericals. So first equation says that V is equals to U plus AT. Right. Second says that S is equals to UT plus half AT square. And the last one is V square is equals to, V square minus U square is equals to 2AS. Now a quick question. In your school, have they derived these equations also? Is the derivation part also important, or only they have done the numerical equations?
I don't know, but she did 2-3 other numericals.
Only. Like she didn't tell you where this equation came from?
No.
Like we have this formula and then we rearranged it somehow? No?
She didn't teach us that yet.
Okay, she haven't. Fine. So let's keep it simple as of now. I'm not doing the derivations. Okay. So now we should know what all these values mean. You know all of them. We have discussed them already. Starting from the first equation, we have U. I told you U stands for initial velocity, right?
Yeah.
That means the velocity which the body has initially when the situation, whatever the situation in the question is given, started, right? Then V is the final velocity. A stands for acceleration, and T here means time, right? Now moving to the next. Small s, I told you in the beginning, small s means
seconds.
no, it means seconds, but we are not talking about the units, we are talking about the quantities right now. So S stands for displacement. I told you that this is a little different, you should remember it.
Yes.
Because it's not directly coming from this, its first letter.
Yeah.
S is for displacement. Then again, U we know, P, yes, others we know. So this is basically the quantities that are used in these three equations. You should like these equations should be in your mind clear. Like learn these equations properly.
Yes.
Because mostly they are not given in the question. We have to apply it ourselves. So the more you will practice, the more fluent you will become in these equations. It's not a big deal. But first, make yourself comfortable with all these new terms, these new system of like naming these terms, right? We use U for initial velocity, V for final, A for this, T for this. You should be clear with this because if you will get confused in this only, moving ahead will become difficult. So learn these equations, be clear with these. Also the SI units. We have not done much. For distance and displacement, it's meters. For speed and velocity, meter per second. For acceleration, it's meter per second square. For time, it's seconds mostly. That's it. That's the only SI units we have done till now. Right?
Yes.
If you want to write it, you can. I'll quickly see if there is any numerical which we can do right now.
Okay.
Let me know when you are done.
Yes, ma'am. Done.
Okay. Now, do you have this PDF that you send me? Do you have that right now with you?
Yes.
Okay. Then we are going to do this example 4.3. It's on page number 55 and page 8 of that PDF if you are viewing it from the PDF. So in this, read the question very carefully. Okay. I'll read it for you. A bus is moving. We are talking about the bus. A bus is moving. Sorry.
Can you tell me the chapter number?
Chapter. This is motion only. Chapter number. Page number. It's page number 55. Chapter 4.
Like the chapter 4, right? Okay, because the school sent us like a link for this.
Okay.
That's why I was asking. I got it now.
Okay. So in this question, they have given us that a bus is moving on a long straight highway, right? With a velocity of 36 km per hour. So what is this? This will be our. A bus is already moving. with a certain velocity that is given us to be 36 km per hour. What is this? Is it the initial velocity or the final velocity?
This is the initial velocity.
Yeah, right, initial, because we are talking about the starting point. Like, what was the condition or situation of the bus initially? So initially, it's moving with this velocity. That means u is given 36 km per hour. Next, they are saying the driver presses the accelerator for a time interval of 10 seconds. So here they have given us a time that for 10 seconds the driver pressed the accelerator. And velocity of the bus increases to 54 km per hour. Now, this 54 km per hour is the
Final
final
velocity.
right?
Mm.
So this is one situation that they have given us. Next, what they are saying, for some time the bus moves at a constant velocity. What is the constant velocity at this moment? This will be the constant velocity because this is what the final velocity was. Like, bus driver was moving, bus was moving with this speed. For 10 seconds, they increase the speed to this. Now the bus will move with this speed only for some time. After that, what happens? Then the driver notices some obstacle on the road ahead and presses the brake. Now he presses the brake. The bus comes to a stop. Stop means that the bus stopped, basically. It stopped moving in a time interval of 5 seconds. So basically, this was the situation one, or you can say case one. It was talking about when the bus was moving with this velocity for 10 seconds, it increased the speed to this one. Now it is moving with this velocity. So in case two, what will be my initial velocity? In this situation only. After
It'll be-
speak.
Okay. No, I can continue.
Like, this was moving first with this velocity. We increased the velocity to this much. Then it's moving with this only, 54 only. Then we applied brakes. And the bus came to a stop. Now you tell me, in this situation, what is the initial velocity? What is the
Initial is
very
54.
good 54? Because now we are talking with respect to this one. After applying the brake, the bus stops. That means
To stop.
final velocity will be
0.
Yes, absolutely right. Very good. And the time interval they have given us 5 seconds. After 5 seconds, the bus stops, right? Now you have to find the average acceleration in the two time intervals. Like you have to calculate the acceleration of this and of this situation also in both the cases. Right? First is when the accelerator was pressed, and the second is when the brakes were applied. So can you find this out? It's very simple.
Yeah.
I told you, after writing what is given to us, what you have to check next?
The data which is given.
Yeah.
And then we have to add the formula.
Yeah, but we have to check what we have to check in the data. We have to check units. Can I place these values directly in my formula or not? Or do I have to make any
Yes.
changes?
The time is seconds.
Yeah.
Over here they've given us.
Exactly. So I can't place this directly. This is the problem. So what we'll do first, we will change. Look, it's easier to convert this into meter per second. The answer will become much easier. So we will simply convert into meter per second. Now I'll tell you how do we do that. If you have kilometer per hour, and I have to change it into meter per second. Now you tell me, in 1 kilometer, how many meters do I have?
1000.
1000. And if I have to change from a bigger unit to a smaller unit, I multiply, right? I hope this much you know. And if I have to go from a smaller unit to a bigger, larger unit, I will have to divide. Now here I am talking about the transition from a bigger unit to a smaller unit. I will simply multiply. And I know that 1 kilometer means 1000 meters, right? Now 1 hour means
16.
1 hour means 60 minutes. And we know that 1 minute is equals to 60 seconds.
Yeah.
Right. So if I have to talk about what 1 hour has in terms of seconds, it will be 60 into 60. Right? Yeah, I have to multiply both of these. So this comes to be 1000 upon 3600. This is how you will convert it. But we can do a shortcut. You just solve it here. 5, 2 5s are 10. So the value comes out to be 5 upon 18 meter second, right? So if you simply remember this value, whenever you have to change, sorry. I hope my screen is still visible.
Yes.
So whenever I have to change from kilometer per hour to meter per second, I will simply multiply that value with 5 upon 18. So here we were having 36 kilometer per hour. So multiply it with 5 upon 18. What will be the answer?
5 upon 18.
36 into 5 upon 18. It will be 10. Right? Meter per second. Now, if I have to convert 54 into, it's 3. Is it? Yes. So this comes out to be 10 meter per second. This is 15 meter per second. This will again be 15 meter per second, and this will be 0 meter per second. Simple, right? Now, if again, remember this, right? 5 upon 18. We will simply. But if I ask you to convert from meter per second to kilometer per hour,
Yeah.
then you will simply multiply the reverse of this. 18 by 5. Okay, so this, either you can write the whole thing 3600 upon 1000, or you can either remember this shortcut that you don't have to do that long again and again. So it's like that. Now calculate the answer for both. Tell me what you get.
Okay.
Place the values now. You can place.
Oh my god. For the first one, I got 15 meter per second.
How?
Because there's 10 right on the like case one, denominator and the numerator. We can just cut the 10, right?
No, we can't cut the 10 like this.
Oh.
No. Do you remember that in maths we use mode mass?
No, I don't know what's mode mass.
Okay, leave it. Listen, whenever you have something going on in your numerator or in your denominator, you can't simply cut it. First, you have to solve this part. 15 minus 10. What will be 15 minus 10?
5.
5 upon 10. Now, because you have them singularly, now you can cut it. So answer will be 0.5, like 5 divide half. And the unit is said meter per second. Unit will be not meter per second, it will be meter per second square because it's acceleration, right?
Yeah.
In this situation, also, I can't simply do this. What I will have to do, first I'll have to subtract this. 0 minus 10 will be minus 10. Because 10 is the larger value here, and its sign will come first.
Yeah, for case 2, I got minus 0.5.
Case 2, it will be minus
0.5 meter per square second.
Minus, it will be minus 2 meter per second square because now we have 5 in the denominator, right?
Yeah.
Right. Now because we have minus, what is this suggesting?
It's decreasing.
Yes, that is as velocity or speed, whatever, it has decreased. So this is, in this case, it's retardation, right? These are the kind of questions we have to do. So that's all for today. In the next class,